Hello, everyone. Very happy to be here. So I'm Flavien. I'm from BCGX. So that's the AI data side of the Boston Consulting Group. And today I'll just go through one of the practical projects that we worked on at BCG. And that's a project that was around helping to build adaptation and resilience, specifically for the food and the water system in the Philippines. Let's go forward. All right. So the context in a few words, we were working in the Philippines with the Philippine government, and the Philippines is a country that is today extremely exposed to climate risk, um, specifically and particularly the agricultural sector. And that exposure is expected to increase quite significantly in the short and long term. And this year alone, there was a prolonged periods of drought that had quite significant impact on agricultural production. And there were visible damage in the fields with stunted sugarcane stocks and sugarcane fields that were much thinner than usual. There was a significant and measurable impact on agricultural yields as well, of the order of 15 to 17%, with obvious consequences on the livelihood of farmers, but also the local population and the economy of the provinces. And so with that context in mind, the project was about working with the Philippine government to try and think of relevant mitigation strategies and help the government build adaptation and resilience for the agri sector of the Philippines. The very first step for us was to try and build a model of the food and the water system for the provinces that we were targeting. So the maps that you see here are maps of a province in the Philippines called Iloilo. And we had to build a model of the irrigation network of the province in order to be able to model the interactions of the province's main crops with this irrigation network. So we built a digital twin of the irrigation network of the province by including water from the main rivers, the tributaries, but also the main infrastructure that are being built today. So all the big dams and the main canals. And that model was supported by extensive data sets that were shared by local stakeholders, by the national agencies, but also local provincial governments. And once that was done, it allowed us to estimate the amount of water that was available for irrigated crops at any point of the province, which meant that was what you were seeing here on the right. We were able to model the interaction of the main crops on the province with the extensive irrigation network. So the red areas that you were seeing on the right were areas where the crops had unsatisfied water demand, and the irrigated crops were able to fetch additional water from the network in order to meet that water demand. We had a model that was dynamically being refilled by rainfall and runoff on a monthly basis. And the availability of the water was also impacted by the usage upstream of the network. So once we kind of ironed out this model of how the main crops were interacting with irrigation network, what we wanted to do was forecast the production of the main crops in the Philippines under the assumptions of specific climate scenarios in the short term, but also the long term around 2050. And in order to do this, we followed a three-step process. So the first step was to estimate the amount of water that was available for the crops. So that's rainfall water minus the runoff plus the additional water from the irrigation network. Once we have that amount of water, the second step was to translate it into an agricultural yield. So we have an agronomical model supported by a library of very specific yield curves that we penalize to model the impact of flash events, such as drought and flooding and waterlogging. Once we have our models of the agricultural yields, we can use the harvested area to translate this into a forecast of agricultural production at any point of the province. This allowed us to kind of land on this picture, which is essentially a agricultural cost of inaction. So this is the projected loss in agricultural production by 2030 and 2050 in the absence of any mitigation measure, right? If we don't do anything specific. And if we just look at the right-hand side, so that's a projection in 2050, it's quite in the long term. We estimated about 15% in terms of average yearly loss in production of rice across the province, which is quite dramatic for a province that's heavily relies on rice production. So now the question is, what can we do about this, right? What are some of the relevant mitigation strategies that we can think of that we can try and design hand in hand with the local government? There were several mitigation strategies that were designed. This is one of them, and it was about deploying small-scale impounding systems. So small water reservoirs that would essentially catch the water during the rainy seasons, and then distribute that water to the crops during the dry seasons through a solar-powered drip irrigation system. And what we wanted to do was to try and estimate the impact of deploying such a solution in the Philippines on the Iloilo province. The first question that we tried to tackle was, where does it make sense to deploy those water reservoirs? So we thought of 4 criteria. The first one is a criteria about the demand. The second one is whether a reservoirs could actually be filled up or would it stay dry at any given location. Third criteria was an absence of alternative, right? Is there no river nearby, for example? And fourth is a feasibility criteria. Is the terrain even enough to actually build a water reservoir without costs just ballooning up? And what we did is we kind of combine all these 4 criteria into a single map, which is what you see on the right. So this allows local governments to visualize which sites are the best suited for deploying those water reservoirs. We try and go one step further and we simulated the deployment of those water reservoirs along the sites that we identified. And we just limited ourselves to a coverage of 30 kilohectares to start with. And doing that, we can essentially visualize the uplift in agricultural production due to introducing those ponds compared to having no ponds, right? And these are the green areas that we see here in the middle. And on an aggregate level, we can just try and calculate the overall impact across the province. And we see that by deploying those ponds in the sites that we identified, we almost fully mitigate the losses due to climate change by avoiding close to 90% of the projected losses in rice production. This was used as the backbone for discussions to attract local investors to try and actually kickstart the deployment of such a solution. It is one of many projects that were discussed. There was another one about introducing climate resilient crops, for example. And we followed a similar framework to estimate the impact of that project. But maybe in the interest of time, I'll just stop there and happy to take any question later if anyone's interested. Thank you.